Hello everyone. Today's lesson, good news. If you already know how to do transformations, then you'll be able to watch this probably whip through pretty quickly. The other good news is if you don't remember how to do transformations, this is going to be a good recap video for you. So we're starting with our base function, which we already know is 2 to the power of x. And some key features, we're going to talk the y-intercept here. The y-intercept of this function is 0, 1. And the equation of the asymptote, that's running along the bottom there, that's y equals 0. Remember that an asymptote is always an equation, written as an equation. It's not just a number. You wouldn't just write 0 there. It's this dotted line, which you can kind of barely see right there. So that's our parent function. Now, exponential function form looks like this. There's a multiplication, an invisible multiplication symbol in there, but we can't multiply a times b directly. We have to, according to the order of operations, work with our exponents first. We'll get more into that later. Function notation form, that's the one that's a little more confusing for us. That's the one that has the f in it, and when there's an f in it, it's telling you you have to go and look somewhere for what is f. In this case, our parent function is b to the power of x, and then these are your parameters a, k, d, and c. So exponential function form looks a little better. It's a little easier to see where everything falls. Function notation form can be a little more complicated. You just have to convert it yourself into both of these forms. So let's talk about our parent function here. It's 2 to the power of x, and 2 to the power of x has this curve, right? It's a sharply increasing curve, and it has an asymptote here. So that's our base or our parent function. Let's get some coordinates on there. So those coordinates, these are coordinates on the parent function. So the first thing we're going to talk about is the c value. The c value, looking up here, here's where the c is. C value is the same thing. It has the same operation as it does for any function. So I'm going to add a number on the outside here, the c value. In this case, we're going to add a 4 on. And that's going to take everything you see here and lift everything up 4 units. So this point 1, 2 is going to go up 4 units. 1, 2, 3, 4, and it's going to land right here. So that's the green. So I don't have all the coordinates typed in here, but that's these are our green graph here matches the green here. This is g at x. It's 2x to the power of 4. So what's really important to notice is that it's all been lifted up 4, but so has the asymptote been lifted up 4. And there's the asymptote. So everything gets lifted up 4. So if you're sketching this along with me here, you can pause if you want to and do a quick sketch of that function there. Now let's talk about when we subtract 4. I think you understand the concept here. We take our parent function, which was in red, and it drops down 4, including the asymptote. It goes down 4 as well. So again, if you're making your own sketches, just pause it here because I'm going to continue on. Let's talk about the d value. The d value. So I'm going to talk about this point here in a second. Here's the first one we're going to do, p at x. So here's our parent function, 2 to the power of x. Now this is a d value here. We have x plus 3. So this is factored, so we don't have to worry too much about this line right here. It's going to come up a bit later, but when you get into the d value, you do have to think about factoring. And if you look down here at the bottom, you'll see the format. So this one here, I didn't include all the parameters. I just had k and d. When we have a k value and a d value, be sure that it looks like this and it's in factored form when you have that. So let's take a look again at our parent function. Our parent function is here. Here's the coordinates on the parent function. Now we're going to take all of these points, and this is a d value. Now remember, there's a minus sign there. That's k minus d. That means this d value is actually a minus 3. So everything here is going to come over 3 units this way. So all of the points like 0, 1 is now moved over 3. 1, 2, 3, it's over here at negative 3, 1. And the asymptote, so technically the asymptote moved 3 units as well, but because the asymptote is infinite and it continues in both directions infinitely, if I move the red asymptote over 3 units, it's going to be in the same spot. So the d value doesn't actually change the location of the asymptote at all. It stays at y equals 0. Now, what about if we have a d value, or if we have an x minus 4? So remember, it's the opposite of what you think because of the format itself. The format itself has a minus sign in it. So that must mean this is actually just the number 4 got put in the spot of the d. Just a 4, a positive 4 was placed right there. So that means we're going to move over 4 units to the right. So again, this point 0, 1, our y-intercept is now over 4 units here, and that's the purple one. And the asymptote is still the same in the same place. It did slide over, but we can't see that because of its infinite qualities. Okay, that's the d value. Now, how about the a value? Again, back to our parent function. There's our a value. Now, what if we have, this time I'm going to use r at x, and I'm using this blue color. I have an a value of 3. Okay, a little harder now. We're not just shifting up and down and back and forth. We're stretching. This is a vertical stretch of 3. That's what an a value of 3 does to any function. It stretches it. So we've got some points here on our parent function. Now we're going to stretch them. So this point 1, 2, I'm going to stretch it up vertically, and instead of 1, 2, it's going to come up here, whoops, to 1, 6, because I multiplied the y values by 2. That's a vertical change. Vertical means changing the y values, right? So all the y values, 0, 1 goes up to 0, 3. So that's a vertical stretch. And what if we had an a value of 1/2? So an a value of 1/2 is a vertical compression. I'm going to take my parent function here, 2 to the power of x. So notice they all have the same base function. These are all 2 to the power of x that I'm transforming. And with an a value of 1/2, now we have a vertical compression. It got squeezed down. So 1, 2 is now 1, 1. And 0, 1 is now 0, 1/2. Okay, so that's an a value of 1/2. It's the same thing the a value does to a parabola or to any function. The a value is a vertical stretch, or in this case, a compression. One more thing we haven't talked about yet with the a value is what do you do if your a value is negative, like with v at x here. We've got our base function, so that's the red one, but then we have a negative in front of it. Well, you know what a negative does in front of a parabola. It takes a parabola that was opening up, like this shape I'm drawing here, and then it flips it down, right? It opens down. So we're going to do the same thing here. I'm going to take my parent red function here, and I'm going to flip it down, and that's what it looks like flipped down. So 0, 1 is now 0, negative 1. 1, 2 is now 1, negative 2. And the asymptote, again, doesn't change with an a value. The a value isn't going to move our asymptote at all. So if you're making some sketches yourself, you can press pause and get some of these written down. Now the k value. So our parent function, k value is a new one for us this year. If for grade 11, watching this video, this is the k value is going to be kind of crammed in here. So k value, let's see what one looks like. There's a k value. That's a k value of 2 right in front of the x. So my parent function is still 2 to the power of x, but now I have this new 2 up here in the exponent. So this 2 that's up here in the exponent is a k value of 2. That's going to be a horizontal change. It's either going to horizontally stretch or reflect, sorry, not reflect yet, stretch or compress. So there we have our horizontal compression. So the point 1, 2 got squeezed in here. So 1, 2 got pushed in. It's now 1/2 2. So I take my x's now. I'm changing the x's. And it's a horizontal change, which means you're changing the x's, not the y's. So my x's, I'm taking all of my x's and I'm dividing them by 2. That's the rule with the k value. You take your parent function x values, and write that down. Oops. You take your parent function x values and you divide them. Whoops, my pen's a little squiggly. X values, we divide them by, in this case, 2. So you take your x values and you divide them by k. So in this case, we're taking our x values and we're dividing them by 2. So let's look at another k value. What if we have a k value of 0.5 or 1/2? So again, we look at our parent coordinate 1, 2. 1, 2 is right here. So 1, 2, I'm stretching it out now. 1, 2, I take my, go back to my pen. I take the point 1, 2. I take the x value, that's the 1. So I'm going to take the x value, that's the 1, and I divide it by k. Right? Remember up here we divide it by k. So I take my 1 and I divide it by k, and here's my k value, it's a 0.5. So I'm taking 1 and I'm dividing by 0.5. That's 1 divided by 1/2, or we invert multiply, and that's 1 times 2, but we get a 2. So 1, 2 becomes 2, 2, which is right here. Okay, let's do another one of those. What if we have e, erase that, we have e of x, and then we've got, there's a negative now. I have a k value that's just a -1. So there's no number, which means an invisible 1, so it's a -1. So it means I'm going to go to my parent function here, and I'm going to, whoops, let me erase this mark here. I'm going to go to my parent function, and it's going to flip over. So all the red values just reflected through the y-axis. So 1, 2 is now over here on this side, -1, 2. That's where the point is there. So that's your negative k value. Okay, so that's the hardest one, I think, because it's the new one for us this year. So that is one by one, all of our transformations, A, K, D, and C. We've gone through all the transformations one by one. So here are some summary points here, and I won't read them to you. You can pause it and read it yourself. This is the big one here. Only changes in the C change the location of the asymptote. So all of the different transformations we did, like the previous one we just did was the K value, also didn't change the asymptote. This is the only one that changes the asymptote. Okay, these are the same thing they've been for every function so far. They're the same. So let's do an example where we're trying to put all of this together now. We've got a base function. No, it's not 2 to the x. It's 4 to the power of x. We've got a base function of 4 to the power of x, and we've got this notation here, right? This is our function notation because there's an f in it. So I have to figure out, with this f now, I have to figure out where do these numbers go? Where's the a, the k, the d, and the c? How do I set this up into exponential function form? So here again are your two forms. Function notation form, everything is kind of on one line here. The exponential function form is easier to read. I can identify things a little easier. So what we want to do is take these numbers and set them up in the proper format. So I can see here in front, right, if I look at my f, right in front of the f, that's the a. So my a must be a -1. The next number is a k, so here's my k, that's a 0.25, which is a 1/4. Remember, we have to factor. That was way back on a previous slide. This is not factored. So we're going to have to factor this out. Let me get my pen here and write that out. So I'm going to factor this out here. I'll write it above. That gives me y equals -f. So open up a square bracket. 0.25. I'm going to write that as a quarter. So that's a 1/4. And then I have x. What's going to be here now? Okay, so I'm factoring 0.25 out of both of these numbers. Factoring is dividing. So I'm taking a 1 and I'm dividing by a quarter there. So that's going to be still plus sign, but that's no longer a 1. That's going to be a 4. So here's what our exponential function form looks like when I take it out of function notation and turn it into exponential form notation here. So this is a lot easier to read. It's a lot easier for me to see what what's happening with all my transformations as opposed to function notation form with the F in it. So one thing I should have pointed out, the base is a 4 here. So where the B goes, remember, for this one, the B, once you convert it to exponential function form, in the B, you're putting a 4, not a 2, like we did on all previous examples. We always did a 2. But this base happens to be a 4. So make sure you've got a 4 there. Okay, so we've got a couple of things we need to do in the question. It says we need to fill in a chart below and draw the graph. So here, let me get the chart up here. So there we go. So here's our chart. We're going to use the coordinate equation method here. The coordinate equation method's really fast, and it's helpful when we are already good with graphing transformations. We don't have to graph them all one at a time. This one lets us do it really quickly. So we start in this column here with coordinates from our parent function. That's in the first column. So our parent function coordinates. So our parent function is 4 to the power of x. So in this column, I want coordinates from my parent function. So let's start with a -1. What is 4 to the power of -1? So that's what I'm kind of working out in my head here. 4 to the power of -1, that's going to be 1/4. So that's a coordinate on my parent function. Now let's move up 1 to 0. 0, okay, what's 4 to the power of, this is supposed to be a -1 here. What's 4 to the power of 0? Well, that's a 1. So that's another coordinate on my parent function. We're gonna do 5 coordinates here. Next one will be 1/2. We can do a 1/2 here. 4 to the power of 1/2. Remember, the 1/2 exponent is the same as a square root exponent. So 4 to the power of 1/2 is 2. And how about a 1? 4 to the power of 1, that's the easy one. 4 to the power of 1 is 4. And let's see if we can fit another one on here. 2. 4 to the power of 2. Okay, that's a bit big. That's 16. That might be hard for us to fit on the grid I've got here, 16. But we're going to do transformations, so that number might, that's 6. We may not have to graph something as big as a 16. So we're going to do transformations. Let me use, how about purple? So what I'm going to put in this column here is I'm going to use this little formula, and I'm going to get the A, the K, so the A, the K, the D, and the C, I'm going to get them all out of this line here. I could go up to this one as well. So the first thing is x divided by k. All right, here's my k value. My k value is a 1/4. That's my k value. So x divided by k is going to be x divided by 1/4. Well, x divided by 1/4 is really 4x. So that's going to be a 4x right there. Plus d, my d value, remember we factored it, so my d value is actually a -4. That's my d value right here. That's my d value. That's a -4. Okay, so that's the first part of my coordinate equation. Now I have a comma because it's a coordinate. This is going to be, the first part here is going to be my x. The second part is going to give me my new y values. A times y. Well, my a value sitting right in front here, even if I go to the originally, I can see my a value is a negative. I have no number there, so I'm just going to write negative y. Oops, sorry. Negative y plus c. My c value is a -1, -1. Okay, so there's my coordinate equation. What I have there are a little mini equation for my x, little mini equation to find my x's, that's this one, and then a comma, and then here are my y's. So now I'm going to take what I had for x's and y's, I'm going to sub them in here for x, sub them in here for y, and I'm going to get all of my new coordinates that will be on my new function. So let me do the first one with you for here. -1 and 4. So I sub in a -1 into the x. So 4 times negative 1, that's my first step. 4 times negative 1, that's negative 4. Minus 4, that's going to be a negative 8. That's my new x value. And 1/4, so 1/4 goes in for the y. So that's negative 1/4 minus 1, that's negative 1 1/4. So that's going to be a coordinate on my new transformed function. So negative 1/4 got transformed to negative 8, negative 1 1/4. So I'm going to get all of my coordinates here, and then I'll be able to graph them. But I'm going to ask you to pause the video here and do the last 4 yourself, do the little mathematical calculations yourself. And after you've paused it and you come back, I will have these all filled in. Okay, so just pause it for a minute, please. Okay, did you pause it? I hope you did. If you didn't, go ahead and pause it now. Get these you should be getting these same coordinates that I did. So what we've got now is we've got our coordinates of our transformed function. So now we're going to graph it. Maybe before we graph it, let me just go over these again here to make sure we all understand what's happening with each of the transformations. So let's first talk about this negative here. We're going to go through the transformations one by one here. This negative is this gives us an a value of negative 1. That's the vertical reflection. So that's right there. That's where that negative went. Your a value in this format that I used here for graphing, the a value goes in the front. That's my negative 1. So the next one we're going to look at is the k value. That's right in front. That's a k value of 1/4. That should give us a horizontal stretch when we're done. Right? Because we actually, remember, dividing by a quarter is multiplying by 4. That's how we get a stretch. That's how our numbers get bigger here, because we have a 1/4. Next is the number inside the brackets. That's actually a -4. Remember, it's the opposite. It's whatever will turn this bracket into a 0, technically. So when x is a -4, we're going to get a 0. So we have a horizontal translation. So everything got shifted 4 units to the left because of that. And our last piece is the -1 on the end. That's a vertical shift, and that's an important one because remember the asymptote? This is the only thing that's going to change my asymptote. So the asymptote, I'm actually going to draw that in first. I'm going to draw an asymptote right across here at -1. So of course I first had to put my scale on. Make sure you do that too. Don't have me guess what you're counting by. Or you're counting. I'm counting by ones, but I'm only labeling every second one just to save some time. And x and y were already labeled on there. So now I'm going to get my ruler and I'm going to draw a horizontal asymptote right here along this line. Okay, so there's my asymptote, which has an equation of y equals -1. It's the c value. So now I'm going to put my other points on that I graphed. And again, I'm going to encourage you to press pause here, graph your coordinates yourself, draw a smooth curve, make it look exponential, and give yourself a minute to do that, and then come back and I will have mine drawn as well. All right, so here we have our graph. I've written the name of the graph there, and there's my curve. I couldn't fit 4 -17 on there, so, but it is a good guide. Knowing that 4 -17s down here somewhere, it does help me to make sure I've got my curve going in the right direction. And I didn't have to graph the parent function, didn't ask me to, but I can see that it's, your parent function going like this. It's got that reflection down there because we have the negative a value. So I'm confident that this is looking the way it's supposed to look. And there's a few other things we want to we're almost done here. Let's just finish this off. Asymptote, domain, and range. So we're going to write those down in there. The equation of the asymptote is, I already have it down here, but it's y equals -1. An asymptote is not a number. Don't just write a -1. An asymptote's a line, so it's got to have an equation. The domain, what is the domain? Well, it's the same as the domain for all exponential functions as long as they're not word problems. and that is x is an element of real numbers, right? No restrictions. Range, we've got some restrictions there. Range is our y values. So we start with real numbers. Yes, we're using all decimals, fractions, positives, negatives. But y is an element of real numbers such that what? Well, such that, look at where the y's are. We're using all these y values here, but none of these y values are being used, and it stops exactly at -1, right? So our graph goes from negative infinity, that's this arrow down here is pointing down for forever, and it goes up, but then we actually hit a wall at -1. We don't actually touch that line, right? The asymptote, we approach an asymptote, but it will never be crossed. So this line is just going to get infinitely closer and closer and closer to the asymptote, but it will never touch it. So that's why we write y is an element of real numbers such that y is less than, not less than or equal to, just less than -1. So that is your lesson on transforming exponential functions.